Welcome to this video. We will learn productivity and good work system design is important. Work system design is the structured arrangement and planning of workplace elements, such as tools, equipment, material flow, operator posture, and environment to ensure high productivity, operator comfort, and safe working conditions. Improves productivity and efficiency, enhances operator comfort and safety, reduces physical and mental fatigue, supports effective material handling, minimizes unnecessary body movement and efforts. What are general principles of work system design? A well-designed work system integrates all these principles to create a productive, comfortable, and safe environment for operators. Accessibility of materials and tools. Operators should easily get the things he wants, so materials and tools must be located within normal working area. They should be close to the operator. If they are available in front to him or her, then it is always better. Like sequential arrangement, materials and tools should be available to operator in the sequence of the need. Hand-specific placement materials and tools should be available to operator in the sequence of the need. Utilizing natural forces in work design. Wherever required, use of gravity principle can be employed in the design of work system, so dropping or inclined slopes, etc. can be kept. This principle helps reduce operator effort and increases efficiency by letting natural forces assist in the work process. Operator comfort and posture. Posture of the operator should be comfortable. Posture of the operator should be comfortable. Extreme movements must be avoided. Under ergonomic seating, chair or stand should be as per ergonomics principle. Ergonomic. Height of the chair should be such that the top of the work table is about 50 millimeters below the elbow level of the operator. Height of the table should be such that the operator can work both in standing or sitting position. Foot rests must be flat, and in movement design, symmetry of movements must be assured wherever possible. Work rhythm is symmetry of movements must be assured wherever possible, minimizing physical strain. Extra human efforts must be avoided. Movement of body should be less. Minimizes body stress. Stress on body elements must be very less or minimum. All parts and materials must be clearly visible. Stacking of materials should not be risky. Workplace environmental factors. Proper illumination at workplace is expected. No shadow or dark spots. Environmental factors, proper lighting, temperature, and noise control for optimal working conditions. Safety considerations built into every aspect of the work system. Temperature should be comfortable. Excessive noise, vibrations must be avoided. Physical interaction with work elements. Pulling or pushing work elements should be in limit. Minimum obstructions in work are expected. In safety considerations in design, avoid sharp corners of machine or material or tools or jigs or handling systems so to avoid injuries. Avoid sharp corners of machine or material or tools or jigs or handling systems so to avoid injuries. Safety devices must be provided at the workplace. Simple displays. Displays should be simple and visible easily. Work rotation and breaks. Short breaks and rotation on the tasks should be used wherever possible. This practice helps prevent fatigue and repetitive strain injuries while maintaining productivity levels throughout the workday. Posture variation. Avoid static postures. Avoid single posture of operator for longer duration. Posture variety. Varied postures or possibilities of doing work in variety of postures helps to avoid yield. For foot pedal operations, posture must be in sitting condition. This ensures proper balance and control while operating foot pedals, reducing strain on the legs and back. Sitting position must be more closer to natural to have comfort in work. A natural sitting position follows the body's normal curves and reduces stress on muscles and joints during extended work periods. Plenty of legroom should be available between each bench and seat. Adequate legroom allows operators to adjust their position for comfort and prevents cramping or restricted blood flow during extended work periods. Eye strain prevention. Minimize eye strain. There should be minimum strain on eyes. This can be achieved through proper lighting, appropriate screen positioning, and regular visual breaks. Noise exposure limits. Safe exposure limit. Below 90 dBA, 8 hours of exposure is safe. Limited exposure. It is unsafe to be exposed to 100 dBA for more than 1 hour. Organization of work materials. Designated storage. Suitable place should be provided for everything connected with the job. This principle of a place for everything and everything in its place improves efficiency and reduces time wasted searching for tools or materials. Workplace housekeeping. Perfect housekeeping. Housekeeping should be perfect at the workplace. Proper storage. Materials should be stored properly. Clean floors. Floors should be clean, free from oil and waste. Facility amenities. Essential facilities. Drinking water. Toilets must be in reach. Accessible amenities reduce unnecessary travel time and help maintain worker comfort and hydration throughout the workday. Safety equipment accessibility. Proximity of safety aids. Safety aids should be closer to the workplace. Quick access to safety equipment can be critical in emergency situations, potentially preventing serious injuries or limiting their severity. Maintenance planning. Systematic maintenance. Provision for periodic maintenance should be systematically done. Regular maintenance prevents equipment failures, extends machine life, and helps maintain a safe working environment. Importance of workplace layout. Productivity. Good workplace layout directly impacts worker productivity by minimizing wasted motion and optimizing workflow. Comfort. Comfortable workstations reduce fatigue and allow workers to maintain productivity throughout their shift. Safety. Proper layout reduces accident risks by eliminating hazards and ensuring clear pathways. Efficiency. Strategic placement of tools and materials minimizes wasted time and movement. Ergonomic tool placement. Materials and tools must be located within a normal working area. They should be close to the operator. If they are available in front to him or her, then it is always better. Tools used frequently should be placed in the primary work zone directly in front of the operator, while less frequently used items can be placed in secondary zones requiring more reach. Sequential workflow. Material input. Raw materials positioned at the beginning of the workflow sequence. Processing. Tools arranged in order of use during the work process. Completion. Finished product placement at the end of the sequence. Materials and tools should be available to operator in the sequence of the need. Hand-specific tool placement. Material or tool to be used by right hand should be kept on right side, and required by left hand should be kept on left side. This arrangement minimizes cross-body reaching and allows for more natural, efficient movements during work tasks. Utilizing gravity in work design. Material feeding. Gravity-fed material delivery systems reduce operator effort. Component transfer. Inclined chutes move parts between workstations without powered assistance. Finished product collection. Dropping completed items into collection bins saves handling time. Wherever required, use of gravity principle can be employed in the design of work system. So dropping, inclined slopes, etc. can be kept. Ergonomic chair design. Key chair features. Adjustable height to maintain proper elbow position. Lumbar support for lower back. Seat depth appropriate for operator. Stable base with appropriate casters. Chair or stand should be as per ergonomics principle. Workstation height relationships. Chair-table relationship. Height of the chair should be such that the top of the work table is about 50 millimeters below the elbow level of the operator. Sit-stand flexibility. Height of the table should be such that the operator can work both in standing or sitting position. Movement, symmetry, and rhythm. Balanced movements. Symmetry of movements must be assured wherever possible. Symmetrical movements distribute workload evenly across the body, reducing fatigue and strain on individual muscle groups. Work rhythm will be give rhythm in work can be possible by correct sequence and apt supply of material. A natural work rhythm increases efficiency and reduces the cognitive load of constantly switching between different types of tasks. Minimizing physical exertion. Reduce unnecessary effort. Extra human efforts must be avoided. Extra human efforts must be avoided when work systems should be designed to accomplish tasks with minimal physical exertion through proper tool selection and positioning. Movement of body should be less. Excessive reaching, bending, and twisting increases fatigue and the risk of musculoskeletal disorders. Excessive reaching, bending, and twisting increases fatigue and the risk of musculoskeletal disorders. Minimize body stress. Stress on body elements must be very less or minimum. Stress on body elements must be very less or minimum. Proper tool design and work methods can significantly reduce physical stress on joints, muscles, and tendons. Extra human efforts must be avoided when work systems should be designed to accomplish tasks with minimal physical exertion through proper tool selection and positioning. Material visibility and organization. All parts and materials are visible. Clear visibility of all components reduces errors and time spent searching for items. Under safe material storage, it may be considered stacking of materials should not be risky. Safety in material storage. Proper stacking techniques prevent collapse hazards and make retrieval safer and more efficient. Proper stacking techniques prevent collapse hazards and make retrieval safer and more efficient. Workplace environmental factors. Comfortable temperature and thermal comfort improves concentration and prevents temperature-related stress. Excessive noise, vibrations must be avoided. Controlling noise reduces stress, prevents hearing damage, and improves communication. In case of force application, panned obstruction management, dulling, or pushing work elements should be in limit. Excessive force requirements increase the risk of musculoskeletal injuries and worker fatigue. Clear work paths. Unobstructed work areas improve efficiency and reduce accident risks from tripping or collisions. Avoid sharp corners of machine or material or tools or jigs or handling systems so to avoid injuries. Rounded edges prevent cuts and puncture wounds during normal operation and maintenance. Rounded edges prevent cuts and puncture wounds during normal operation and maintenance. Safety protecting devices must be provided at the workplace. Guards, emergency stops, and other safety features prevent accidents and minimize injury severity. Displays should be simple and visible easily. Intuitive displays reduce operator error and improve response time in critical situations. Avoid single posture of operator for longer duration. Varied postures or possibilities of doing work in variety of postures helps to avoid yield. Short breaks and work rotation on the tasks should be used wherever possible. Below 90 dBA, 8 hours of exposure is safe. It is unsafe to be exposed to 100 dBA for more than 1 hour. For optimal workplace conditions, noise levels should be maintained below 85 dBA when possible. Hearing protection should be provided when noise levels cannot be adequately controlled through engineering solutions. These principles using for work system design benefits in increasing efficiency, ultimately increases productivity.